In this video, I'm going to be making this. This is a lathe centering tool. It's a really handy tool for centering parts on a lathe. The first thing I needed to do was cut off a piece of stock for the actual lathe tool. I had some 1/2-inch tool steel laying around from a previous project, and that was the perfect size to fit into my lathe tool holders, so I just used the bandsaw to cut off a 6-inch section, and that should be big enough for what I need. The next step is to move this over to the mill. I'm going to do this in 2 steps. I'm going to do one end and then I'm going to repeat all those steps on the other end. The first thing I want to do though is indicate the edge of the piece. So I'm using my electronic edge finder to find the edge of that, and I'm just going to run a really simple CNC program that just rounds off the edge of it and then drills a hole. For the x-axis, I'm using a 1/2-inch end mill to shave off the edge. That gets rid of the nasty cut from the bandsaw, also gives me a clean edge to start with, and gives me a nice place to reference off of. Since it's a 1/2-inch end mill, I can take half of that, which is a 1/4 inch, and use that as the offset, and then I can easily zero off the edge of the piece. I've always liked this little trick for setting the Z height. You take a piece of paper, like a post-it note or receipt or anything you have laying around, and you put it on top of the workpiece, and then you slowly lower the Z down into the workpiece while wiggling the piece of paper. And while you do that, you wait for it to stop wiggling, and that means that the bit is touching the paper and also touching the workpiece, and then you just kind of deduct out the thickness of the paper. It makes it really easy to set the Z. So after the Z is set, it's just a matter of running the little program that just kind of rounds off the edges, and then it's time to drill the hole. I'm drilling a hole which I'll eventually tap to an M8 thread. The reason I'm using an M8 is because that's really the only screw that had like a button head at my hardware store. I could have either done a 5/16 or an M8. Both of those are approximately the inner diameter of the skate bearings. I just went with an M8 because I already had a tap on hand and it was a screw that I could easily find. I'm not really a big fan of tapping, and I'm definitely not a fan of tapping tool steel, especially with, kind of old, inexpensive taps. So this wasn't too fun, but it came out okay. I went and duplicated the profile and the hole on the other side, so I've got 2 radiused corners. And I've got my skate bearings and washers, and so the M8 bolt goes in like that, and you have a washer, and I have a duplication on each end, as you'll see in a minute. It's basically so I can put it on 2 different positions on the lathe, and I don't have to move it in and out of the tool holder. So I'll just screw these down, and then screw it into the tool holder, and we'll actually see how it works. Here I've got it mounted in my quick change tool holder, and it has the 2 bearings, so you can mount it either on that side like that to go off this surface, or you can switch it around to this other side and go like that. I've got an indicator mounted up against this test piece that I had, and if we zero it out and spin it around, you can see it's moving somewhere around 15 clicks. Each click is a 1/2 thousandth, so overall it's moving anywhere between 7 and 8 thousandths of an inch. To use the centering tool, all we need to do is loosely chuck in the workpiece and then slowly slide the carriage into it until the bearing spins, and then back off. And here it is after we've centered the part. So it's going about 4 ticks or so, which is about 2 thou, which is pretty decent for the finish on the outside of this part, this chuck, and this dial indicator. So helped it out quite a bit, and 2 thousandths is plenty good for what I do.